We're finding intercepts. The x-intercept, what did you tell me to do? Put 0 in for y, and I'm looking for the x value. Is that an easy thing to solve for? When I have something equal to 0, what are my strategies to solve for that? What would you do? Okay, we'll kind of put those here just as a reminder. What are our strategies? What else could I do if it wouldn't factor? What's my other option? Quadratic formula, and that's about the only options. And so oftentimes I won't ask you for that x-intercept because it's difficult to find. So what do you know about your y-intercept then? How would you find that? What was that ordered pair looking like? Yeah, so you insert 0, and that's much easier. Would you agree? Because oftentimes those are all going to go away. We already have looked at symmetry. Let's just remind ourselves we're only looking at 2 types of symmetry. And a key feature are the exponents. That's kind of my clue, but as you found on the test, just telling me odd or even or neither is not going to work. You have to check f at negative x. And I had a question yesterday about that. Actually, I think it was Whit. He was wondering how and what it meant again visually. So if I say it's odd, and that means it's symmetric about the origin, where's that point going to land? It went from quadrant 1 to what quadrant? And so what do you know about its ordered pair in quadrant 1? They're both positive. What do you know about its coordinate in quadrant 2? So that says if I plug in a negative x, I'm going to get out negative my y value. Remember, f of x is y. I'm going to get negative y out. And that tells me it's odd. Even, on the other hand, says if I plug in negative x, I'm going to get my original function back. Here's a picture of that. My point is right here, which is xy. If I'm symmetric about the y-axis, I land over here, and what's its ordered pair? So it says if I change and put in a negative x, what's my output? If it is even, the y's remain the same, and you can visually see that. Does that help with the even odd, or did you already kind of have that all right? Are you all right with that? Okay, so you're going to have to test to determine if it's not all opposite or all the same, then you know it is neither. So now let's look at domain. So what do you know about domain? X or y? Okay, so it's the x values. And range obviously is the y values. So when I'm looking at my domain, there's 2 types of functions that really create some havoc with the domain. What are those 2 types? When would I have issues with a domain? Kind of. Okay, when I have a fraction. Square root functions, yeah. Okay, as well as trig functions. Do trig functions have problems? Tangent does, doesn't it? Right. So we'll be talking about trig functions in a few days. All right, asymptotes. So again, this is just a review of really what you did in Algebra 2 and pre-calculus, but now we're going to use kind of the calculus direction to finding them. Do you remember how you found a vertical asymptote? Denominator equals 0. That's my problem spot. That's correct. So we could use calculus to do that. If I was using calculus to do that, I would be looking at something like this. The limit as x approaches some value, and it would be where this limit of whatever my value does not exist. That's when I would have trouble. Is when my derivative does not exist, or when it goes to who? Infinity, yeah, because if you look, I'm headed to infinity or negative infinity. So that's where you're going to have issues, is where does this limit go? What value does it approach when it goes to infinity? And we'll be talking about that, but let's just think about all these different things and we'll put them all together. What about the horizontal? Good. The limit as x approaches infinity. That is how you will find horizontal. You don't want to do the long division. You already kind of knew that yesterday or the day before when we were talking about this, about limits as it went to infinity. So you kind of already were expressed like, oh, I can do that, but now we're just going to express as a calculus. Okay, what about a slant asymptote? Oh, when do I have a slant asymptote? When what happens? Do you remember? Numerator. What do you mean numerator what? What's bigger? 3's big. Greater than denominator. You did. I think you learned a lot. Sometimes it's just memorizing, or remembering, I shouldn't say, memorizing. So that would have a slant asymptote. Okay, this problem would have a horizontal asymptote. Where would the horizontal asymptote be? 3/2. Okay, make sense? This problem would have a horizontal asymptote. Where would it be? Okay, so how do I find my slant asymptote? Can I still do this infinity thing or not? I can't, because horizontally, that's when x gets large. These things are changing. So a slant asymptote, if you're not sure what we're asking you to do, can you remember maybe a graph like this? And your graph was either in the side. Remember that? There's really only one way to do this. And unfortunately, it comes back to this. Long division. So some of us may need to practice our long division. And we will. Okay, so we have 3 places where extrema occur. One place is where the derivative is equal to 0. We're going to call that would give me my critical value. Okay, what happens in the next place? What do you know about the derivative? This was kind of your test question that we struggled with a little bit. How do I know that I have a maximum? And how do I know that I have a minimum? So what happens if my derivative is greater than 0? What does that tell me about my function itself? It is increasing. And what happens when my derivative is less than 0? So I use these signs to tell me if I have a maximum or if I have a minimum. If that's my maximum, how do I verify that that's a maximum? Because I increase and then decrease. And just opposite, decrease, increase is going to give me that minimum. Questions about that? Okay, concavity. So when I set my second derivative equal to 0, and I find that point, what's that called? What's that point called? So we're looking at this. That's called the point of inflection. So again, something you just took a test over. Just trying to remind you of it because it's still going to play into these other graphs that we're going to do. What do you know about my second derivative greater than 0? Concave up. And my second derivative less than 0? Very good. Okay. So let's just remind ourselves, just had a test over this. Let's just remind ourselves, it was just a straightforward polynomial. No issues with it. Could you find your x-intercept? I would ask you to find your x-intercept on this. How would you do that? Does this thing factor? Oh, I think both signs are of subtraction. Sorry about that. Kind of factors. Does that factor? Does that work out? All right, so Quaid wants to do this now. Are you okay with me writing it like that? Because I'm going to get 2 from this one, 2 from this one. They're both the same, 1 minus, 1 plus. Are you all right with that? So how many x-intercepts are there? There are 4, but it happens that 2 of them are the same. What happens when we have 2 things that are the same? What happens in your graph? Is it a pass-through or a bounce? So there are my x-intercepts. So I have to be thinking, gosh, maybe I'm going to have a bouncy thing here. My y-intercept, hopefully that's not an issue with you. You'd be asked to find that for every graph. Everybody's okay with that? All right, symmetry. What do you think just by looking at it? Even. That's not enough, but I agree with you. So how would you verify that that's even? And when I take it to the power of 4, and then I take it to the power of 2, and I add on 16, two negatives made that positive, so I have minus 8x plus 16. I notice it's the same of f of x, therefore it's even. So when I go to graph this, and this is what some of us forgot to do, when I go look at the graph up here, I automatically know I'm going to plot these points here. 0, 16 is someplace up here. I've got a positive 2 and a negative 2. I already know from previous experience I'm going to have some bounces on those points, but I also know that it's symmetric about the y-axis. Does it starting to look symmetric about the y-axis? So when you're done, you make sure your graph matches that symmetry. Are there any asymptotes to this polynomial? There are no asymptotes. Asymptotes occur when you have what kind of function? Not a polynomial function, but a what? Oh, what's another formal name for a fraction function? You never hear me say, we got the fraction function. It's a what? Rational. Yeah, rational numbers. Remember, rational numbers are fractions that terminate or repeat? Okay, so we don't call them fraction functions. So just so you get kind of that language down. All right, critical points. What were you taught to do to find these? What are they, first of all? Possible what? Peaks or troughs, mins or maxes. So I'm going to find f prime. So that's 4x cubed minus 16x. Let's see. Then what do I do with that? All right, as I'm setting it equal to 0, I'm going to take out a 4x, and I'm going to get x squared minus 4. So I get 4x, x plus 2, and x minus 2. So how many critical values do I have? How many critical values do I have? And how could I have known that before I went on and did all this work? It's cube, right? This is one, here's your second, and here's your third. So if I'm asking for values, you would tell me, what are they? But if I'm asking for points, which it says, what would I need to do with those? I already know 16. Good, and you know to plug back in the original. Let's see, negative 2 to the 4th is 16, and 16 is 32. Minus 32, I believe it's equal to 0. Did you get 0 out? I believe this one's 0 too. Are you okay with that, or am I off base here? Oh, we did. Okay, yeah, we did, didn't we? 2 16s are 32, and 8 times 4 is the negative 32. So intervals for increasing and decreasing. Even though you think you know, you have to verify for me. So where would my interval table go starting from? Negative 2 to 0. Would I need to include 0 in this table? Obviously I did, but for what reason? And I know that this is squared, and I know that this is squared, and that's my original function just broken down into its components. So no matter what I do with squares, what am I going to get? Oh, do I need to put the 4x in there as well? Oh, gosh darn, what did I start putting in my table? Help me. The original function. Dang it. I was like, this isn't going to work out. So yes, I do need to put the 4x in. 4x, x minus 2, and x plus 2. So good with that? And now I'm just plugging in these numbers. What's going to happen here? I think this one is where it turns positive. So I got decreasing, increasing, decreasing, increasing. Look okay? I'm thinking I can go sketch my graph now, because I know that I was, let's see, I started decreasing. I had to hit here, and then I had to begin increasing in my next interval from 0, negative 2 to 0. Now from 0 to 2, I'm decreasing, and now from 2 to infinity, I'm increasing. So now I've got to look here. I should just kind of tell from my graph that I'm going to get my second derivative to be what in this area? And what's going to happen here? And it looks like it's going to come like this, and at some point it had to change to become again concave up. Would you agree with that? Does that seem okay? So how many, just looking at it without finding them yet, how many points of inflection does it look like I might have? All right, so let's go see if that's the case. So I take my second derivative and I get 12x squared minus 16. I once again set it equal to 0, but I think I'm going to take out a 6 first, and I get 4x. Oh, goodness sakes. What am I going to take out? 4. Thank you. And I get, oh, yuck. 3x squared minus 4. Are you okay with that? All right. This doesn't have a 0 to it. Some of you are thinking that 4 is equal to 0. 4 can never be equal to 0. 4x, however, can be equal to 0. So I only have this spot in which to concern myself with. Move the 4, divide by 3, take the square root. Don't forget there are 2 of them. And the square root of 4 is 2 over the square root of 3 is 2 over the square root of 3 some value. Is it some value? It's equal to a value. In fact, I've noticed that that would be these 2 points on my curve. So they're between 1 and 2. I don't really care to find their value, but I am going to set up a table, -0 to -2 over the square root of 3, -2 over the square root of 3 to +2 over the square root of 3, and +2 over the square root of 3 to infinity. Constructing my table. I need to be careful. What goes in my table now? Oh. Yep. So who goes in my table now? I got rid of all that stuff because I want to see, yes, 4 and, can't write it any better, can I? 3x squared minus 4. I know that for sure. So I'm going to try -3 because I know -3 is in that for sure. And if I plug -3 in, I get 9, so I can see it's positive. I'm going to try 0 because I know it's within there for sure, and I see that that's negative. And over here, I'm going to try +3, and I see that that is. So in this region, I'm up, down, up. Now, I need to check. Does that match what we had here? Up, down, up, down, up. So what's this? What is this value? Notice I didn't say point. What's that value? And what's this value? What's perfect. Okay, so that's just a review. That's probably a 15-minute review. You have any questions on polynomials now? You did very well on the test on graphing that polynomial, that's for sure. So we're going to move to this one. Rational functions. So this is our fraction function, if you will. And so if I am trying to do this, it's pretty much the same deal. You go through the same steps. Do you already have an idea what this function looks like? Don't you? No idea? Okay. So x-intercepts, how do I find them? How do I find x-intercepts? No different than the, look on the other side if you have to. How do you find an x-intercept? Who gets to be y? Or sorry, who gets to be 0? I just told you. When is a fraction equal to 0? Only the numerator. Kuwait is right. Only the numerator. Would you agree with that? So give me the value in the numerator, 0. All right. Check that one off the list. Got that one figured out. Y-intercept says when I plug 0 into my function, what do I get out? Will I always have an x or a y-intercept? No, because that x and y axis could become asymptotes. Very good. Symmetry. Still have to check it. F at -x, and I get -x plus 3, -x plus 2. Compare my result with my original function. Perfectly a match or directly opposite each other in either one? Agree with that? Questions about that? If it was going to be directly opposite, the +3 and the +2 would have been negative. So let's find our asymptotes. I always like to start with the vertical myself because I think it is the one I don't have to do as many calculations for. What's my vertical asymptote? So I'm going to write it as x equals -2. Remember, it's not a point, it's not a value, it's a line. Okay, and you'll be docked if you don't write it as lines. Okay, tell me about my horizontal. Oh, wait a minute. How do I know that I don't have a slant asymptote? I check my powers and they're the same. So I know it's horizontal and you'll have to find it. So to find it, I take the limit as my x gets super large of 3. I want x plus 3 over x plus 2. So I'm going to divide by the largest power in the denominator, and some of you can see this answer already. Goes to 0, goes to 0, goes to 1, and goes to 1. So what's my answer? 1 over 1, which is 1. So I have to write it as a line, y equals 1. So I have my two asymptotes. Critical points, how do I find that? Okay. How do I take a derivative of this different function now? It's been a while. Quotient, okay. Derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. Can I cancel the 2x plus 2's, one in the top and one in the bottom? Can I cancel those? No, so I'm not quite done. Do everybody agree I can't cancel the x plus 2's? There's only 2 of them. I need 3 of them, one for each term. So if I start to simplify this, let's see, I'm going to distribute this negative here, and it goes to both the x and the 3. The 1 doesn't bother me. What happens to your x's? And so my numerator turns into -1, my denominator, x plus 2 squared. Okay, so what do I need to do with that? Okay. Is that fraction ever equal to 0? So does that mean I don't have critical points? So f prime of x is never equal to 0. Is that the only place I need to check for critical points? Where does it not exist? Give me a value for that. Okay, can I make -2 a point, or is this where it has to stay a value? Tells me to make points. Can I make a point out of -2? Okay, let's do that. Can it fit into the original one? So is it just stay a value, or can I write it as a point? It has to just stay as a critical value, doesn't it? Because I can't make a point out of it because it's undefined. But I can still make a table, -infinity to -2, -2 to infinity. Do I need to slow down a little bit? You okay with what we did there? What do I put in this table? Don't let me make that mistake again. What goes in the table? So can I break it into 2 pieces? Because if I'm dividing, isn't that the same as multiplying? -1 is always negative. What do you know about the second piece? So what do you know about this graph? So it's always doing what? Oh, that seems weird. It's always decreasing. All right, marching on. What's my second derivative? So I can find my points of inflection. How would I do that? Derivative of the... I could. It looks like I'm out of space, so can I just leave it as a fraction? Is that all right? Derivative of the top times the bottom, 0 times anything is gone, minus the top times the derivative of the bottom, there is no chain, because the derivative of the inside would be 1, over the bottom squared. Can I reduce this fraction before I go further? Should it be to a power of 4? Sorry. A squared squared is a power of 4. Can I reduce this now? All right. So how are you going to reduce it? What are you going to reduce on this? One of these only makes 3 of them. Okay, and it looks like 2 over x plus 2 to the power of 3. So that is my second derivative. What am I supposed to do with that? Okay, we do so. Is that fraction ever equal to 0? No or yeah? Yeah. Where's that fraction equal to 0? Is it ever equal to 0? Second derivative is never equal to 0, but we have to test the other things. There's no endpoints. I don't need to worry about those. What's the other thing I need to worry about, the second derivative? Where does that occur? Table, negative infinity. So do you see how this is what you've already done before with polynomials? It's just a little bit different graph. And we're going to get some more difficult graphs so you can see the purpose of doing all this. Now the purpose is probably we could pick up a calculator, but we're trying to use our calculus knowledge to come up with these graphs. So I've got a 2, which I know is always positive. I've got an x plus 2 cubed. So when I put a negative in and cubed it, it's negative, positive, so it tells me a graph is down and up. All right, so we haven't even started to sketch any of this, so let's try to get a picture of what we have going on. So I'm going to scroll back up here so I remember it's not going to be symmetric. What's that? Okay, we're going to plot some points, and we're going to get some asymptotes. So let's see if I can remember this. Negative 3, 0 is a point I'm going to plot. And 0, 3 halves, is that correct? 0, 3 halves is 1.5. I have some asymptotes, and one of them occurred at x equals 2, is that right? Negative 2, sorry. And where was my horizontal at? And my graph was always decreasing. And I know I have to hit that point. So my graph follows asymptotes, and it's always decreasing. Would you agree with that? In addition, does my concavity match? Okay, in the next region, I still have to be decreasing, following asymptotes, and I must be concave down. Does that match? There you go. All right, so for homework tonight, you just need to do one problem, and I'll give you the rest of the class time to do that. I think you've listened to me enough. I want you to practice on this one, and we'll correct it before you leave. And then we'll just kind of beg homework for the weekend. We'll do one more example in class tomorrow, or sorry, on Monday, and then we'll spend a couple days just graphing. But you okay with this? You already kind of know what the picture looks like for these. All right, it'll get a little bit more difficult as we get kind of crazier graphs.